Hello everyone. In this module, we are going to discuss some mathematical functions in NumPy. Till now, we have covered some basic functions in NumPy, and now we will discuss some mathematical functions that can solve mathematical problems. So in Python, we can implement the mathematical operations based on these functions, such as trigonometric function, rounding function, and hyperbolic function. So let us briefly discuss these mathematical functions. So our first function is trigonometric function. So basically trigonometric calculation can be performed in Python by using built-in functions that define in the NumPy module. By using the NumPy module in Python, the number of lines in the code can be reduced to a minimum, and it also helps the user to calculate the tangent, sine and cosine angles in radian. Now we will understand the trigonometric functions which are used in Python NumPy. The following given table are the most important trigonometric functions which are used in Python NumPy. So our first function is NumPy.sine function. This function is basically used to calculate the values of the trigonometric sine function, and it will return the sine value of the angles in radians or degree. You must multiply the angle with np.pi divided by 180. So in Python, np.pi will return the value of pi, which is 3.14. So here is the syntax of numpy.sine function. There are only 4 parameters which we are going to use in our example. The first parameter is x. So this parameter specifies the input array on which the sine function will be implemented. The next one function is out. By default it takes a none value and it is an optional parameter. So it specifies the location where the result, and the next one parameter is where. It is an optional parameter and it will check the condition. If the value is true, then the universal function is calculated at that position. So our last parameter is order. So it specifies the memory layout of the copy. By default it takes k value, which means the layout of the input array as closely as possible. Now let us see an example of how to use the numpy.sine function on a numpy array of values. So in this example we have created a numpy array of two evenly spaced values by using numpy.arrange function. Now that we have an array of random values, we will calculate the sign of those values by using np.sin function, and within this function we have assigned the array as an argument. So in this example we have started the value with minus np.pi and stopped with positive np.pi value. So after executing this code, the output comes the sign values of each element of that given array. After calculating the sign values, now we will understand the numpy.cos function. This function is used to calculate the cosine of each element in an array, and if you want to find the cosine of an input array of angles that is given in degrees, then you can easily use the numpy.cos function. So if you want to calculate the cosine of a single number and an array of numbers, then this function will help the user to get the cosine value of the angle in radian form. So here is the syntax of numpy.cos function, and within this function we have used only two parameters. The first one parameter is x. This parameter specifies the input array which we want to compute the trigonometric cosine. The next one parameter is out. By default it takes none value and it specifies the location where the output must be stored. So let us understand how to use the numpy.cos function in Python. So in this example we have created an input array by using the np.array function, and within this function we have assigned the angle, and now we have to calculate those angles. Next we use the np.cos function, and within this function we have assigned the array with the multiplication of pi value. So after executing this code, it will convert the angle into a radian form. So our next function, that is numpy.tan function. So basically this function is used to calculate the trigonometric tangent for all the elements of the array which is passed as an argument. So within this function there are only two parameters. The first one parameter is array, and it indicates array elements whose tangent values are to be calculated. The next one parameter is out. It specifies the shape of the output array. So it always returns the corresponding tangent values of an array's element. Now let us see an example of how to use the numpy.tan function on a numpy arrays of value. So in this example, we have created an input array by using the np.arrange function and assigning the values. So the numeric value starts from 1 and ends with 4 into numpy.py value, which means multiplication of 4 with pi values, and the step value is 2. Now to find the tan of an input array of angles given in degrees, you can easily use the numpy.tan function. So within this function we have assigned the given input array as an argument. So after displaying the tangent values, we will show the graphical representation of tan values by using the dot plot function. Till now we have understood the trigonometric functions based on NumPy. Now we will understand the inverse of trigonometric functions which are used in NumPy array. So our first function is numpy.argSine. So basically this function is used to find the inverse of a sine value wise of an input array, and this function will take two parameters. One is the input array on which the inverse sine values are to be calculated, and the other one is out that specifies the shape of the output array. And the next function is numpy.argcos. This function is available in the NumPy package and it will help the user to find the inverse cos of the input array element. So basically this function also takes two parameters, that is input array. Our last function is numpy.argtan. This function is used to calculate the inverse of a tangent array of elements. You must use the numpy.argtan function and this will always return an array containing the inverse tangent values for the input array. Now let us take an example to understand the concept of these inverse functions. So in this example, first we have created an input array and then converting the angles in a radian form by using np.sin function. After displaying the sin values, now we want to calculate the inverse of a sin values by using numpy.argSine function. So within this function we have assigned the result variable, that is our sin values. So after executing this code, the output comes the inverse of the sin value. So in the case of numpy.argcos function, we have created an input array by using np.array function, and within this function we have assigned the numeric integer values. So after creating an array, we have used numpy.argcos function, and within this function we have assigned the given input array. So after executing this code, the output comes the inverse of the cos value. So in the last function we have used numpy.argtan function and it will return the inverse of the tan value. Now we will understand our next mathematical function, that is rounding function. So basically this is a built-in function that is available in the NumPy package and it performs rounding of operation. So we can also specify the number of floating place that we want to round off. For example, suppose we have a decimal values in an input array of 2.56, then it will return as a rounded figure. In simple words, it will round all the values and the output will be a new array. So here is the syntax of rounding function, that is numpy.round is the function name, and within this function there are three parameters. The first one parameter is a. This parameter specifies the input array which we want to be rounded off. The next parameter is decimals. By default it takes 0 value and it specifies the number of floating places that we need to be rounded off. The last parameter is out. By default it takes none value and it specifies the location where the output must be stored. Let us see an example of how to use the numpy.round function on a NumPy array of values. So in this example we have declared the array values in the form of decimal values and then use the np.round function and declare the decimal values as 1. So after executing this code, the output comes array values will be rounded off up to 1 decimal. So now we will understand our next mathematical function, that is hyperbolic function. Basically the hyperbolic function is defined as a group of functions of an angle relationship between the distance on a point of the hyperbola. NumPy also provides various hyperbolic functions and these are the functions are used to calculate the hyperbolic functions on a NumPy array. Now we will briefly understand about this function. So our first function is sin h, that means sin hyperbolic. So this function will help the user to calculate a hyperbolic sine of the values, and it will check the condition. If the number argument is negative or positive, then this function will easily return the sine value. Our next function is that is cos h. This function is used to calculate the value wise hyperbolic cosine of a given array. Our last function is that is numpy.tan h. So this function is used to calculate the hyperbolic tangent for all the values of the input array and assign as an argument. Now let us take an example to understand the concept of these hyperbolic functions. So in this example we have created an array named as a sample values, and within this function we have assigned a value that is integer and pi value divided by 4. So after creating an array we have used the numpy.sineH function, and within this function we have assigned the array as an argument. So after executing this code, the output comes the sine hyperbolic values. Now in this example we have used the np.tanH function, and within this function we have assigned a given input array that is real numbers. So after executing this code, the output comes the tan hyperbolic values. So with this we have completed the mathematical function in NumPy.